Okay, let's dive into this. What if our computers weren't just incredibly powerful calculators? I mean, what if they were more alive? Today, we're going to explore a really radical new idea in computing that leaves the whole world of ones and zeros behind for something, well, something a lot more familiar.
And that really brings us to the big question at the heart of all this. What if our computers actually worked more like nature does and less like the calculators we've built them to be? Just think about it for a second. Living systems, they have their own rhythm, their own memory, their own sense of balance. Our current tech, for all its power, might be missing the most fundamental thing of all. You see, the computers we use every single day are, in a way, blind. Yeah, they're absolute masters of logic, and they follow instructions with unbelievable speed. But they have zero understanding of context or history or rhythm. They calculate, for sure, but they don't evolve. So how do we fix that blindness? Well, the answer isn't just a better algorithm or a faster chip. Nope, it's about going all the way back to the very basics and completely reimagining the most fundamental unit of computation itself. We've got to go beyond the bits and bytes we all know.
This slide really gets to the core of the idea. On one hand, you've got the bit. It's just a static switch, right? It's on or it's off, 0 or 1. But on the other hand, we have something totally new, the orbit. It's not a static value at all, it's a living rhythm. It's this ongoing motion. So we're moving from a single, frozen snapshot in time to a continuous, evolving story.
So what exactly is this living rhythm? It's time to properly meet the star of our show today, the orbite.
At its heart, an orbite is basically a tiny rhythmic vibration that has three key properties. First, you've got its phase. That's just its position in the cycle, like where a pendulum is in its swing. Then you've got amplitude, which is the energy of that swing. How big is it? And finally, there's coherence, which is just how stable that rhythm is. Is it a nice, clean, steady hum, or is it all noisy and chaotic? These three things together create this rich, dynamic unit that's so much more than a simple on-off switch.
And I want to be super clear here, this is a complete paradigm shift. As you can see, an orbite isn't just a better bit. It's not a simulated neuron. It's not some new kind of logic gate. It is a fundamentally different kind of thing. It's a tiny dynamical system that computes through its own natural motion and how it relates to everything around it, not by storing some abstract symbol.
So here's the big takeaway. Traditional bits store a single static value. An orbite, though, it stores a trajectory. Its entire history of movement and interaction is literally baked right into its current state. And that means computation is no longer about just processing these frozen snapshots of data. It's about watching patterns evolve over time. Okay, so we have this brand new fundamental unit, the orbite. But what happens when you actually build an entire computer out of them? Let's scale this up and try to imagine what that would even look like.
I want you to forget motherboards and processors and circuits as you know them. Instead, imagine a computational fabric that's more like a living tissue. It's this lattice, this mesh of tiny interconnected orbites, all influencing each other. In this world, computation isn't executed like a program. It just emerges from the collective dance of waves and resonance and harmony within this whole system.
This new way of thinking just completely collapses the traditional structure of a computer. The processor, the memory, the runtime, they're not in separate boxes anymore. They all merge into one single unified thing. And memory isn't a grid of addresses. It's more like a seasonal landscape of all the interactions that have ever happened. The system doesn't run a program. It simply evolves in response to what's going on.
And this all leads to a really profound insight. The act of computing is the act of remembering. Think about it. If an orbite's current state is its history, then changing its state, which is computing, is the exact same thing as changing its memory. They're totally linked. The system literally computes by evolving what it remembers.
Okay, a computer made of living tissue that remembers. I know, this might all be sounding a bit like science fiction, but what's so fascinating is that there's a really clear, practical pathway to bring this dream into reality.
This whole journey happens in three key stages. It all starts with the ideal physics. That's the conceptual model, the North Star we've been talking about. Then, that concept gets tested using FPGA prototypes. FPGAs are these really cool, reconfigurable computer chips that are just perfect for building early hardware that can emulate this physics.
And finally, to get it into everyone's hands, there's the software sandbox, which simulates the entire system so it can run on the phones and computers we already own.
This table does a great job of clarifying the different layers. Let's just walk through it. Up at the top, you have the ideal. That's the ultimate goal, right? A custom chip running on pure continuous physics. Then in the middle, you've got the FPGA stage. Think of this as the hardware test bed, where the whole idea gets validated using emulation. And then down at the bottom is the software, and that's what's running today. It's a simulation on a normal CPU that lets us experience these principles in an app right now.
So we have this radical new concept, and we've got a clear plan to build it. But this brings us to the most important question of all. Why? I mean, beyond the fascinating physics and the cool engineering, why does any of this actually matter?
Well, the ultimate goal here is to fundamentally change our relationship with technology. We're trying to move away from a tool that just follows commands and toward a co-regulating digital partner. Imagine technology that doesn't just react to your clicks, but can actually sense your cognitive state, like maybe you're stressed or losing focus, and it can subtly adapt its own rhythm to help you find balance again. That's the real aim here.
And if this works, the long-term implications are just staggering. We're talking about a whole new generation of truly intuitive interfaces, technology that could actively help us regulate our own emotional states, and it just scales up from there. The source material even points to new kinds of large-scale collective coordination, things that could potentially change our economies at a really fundamental level. This is a vision for a completely new technological foundation.
So I'll just leave you with this final thought. Right now, our technology thinks for us. But if our technology could not only think with us, but, in a way, feel with us, responding to the world with rhythm and memory and coherence, how would our world and our relationship to it truly change?